So in this video, we have the domain and range using interval notation, and on the front are the definitions that you want to record in your notes. So domain is all possible x values in a relation, read left to right. The range is all possible y values in a relation, and that's read from bottom to top. Remember that a relation is any set of ordered pairs where the x is first. It's your independent variable, and the y is listed second in the ordered pair. That's your dependent variable. Or it's an equation with x and y as your variables. And then a function is any type of relation where each x value pairs with exactly one y value, which means graphically it'll pass the vertical line test. And we went through these definitions pretty quickly because this is just review from Algebra 2. But we're going to go through some examples together and take what we learned yesterday or in our last lesson regarding interval notation and apply it to finding the domain and the range of a relation or a function. So in example 1 in the notes, these are all examples of bounded relations. And recall, when you want to find the domain, you start from the left and then head to the right because you're looking at x values. So our lowest x value on this graph is going to be here. This is at x is -1 because that's the point -1, 1. And then our highest x value on this graph is over here on the right, where the x is 3 and the y is 1. And since domain is x values, we're going to start with the smallest x value, which is included because it's a closed circle there. So we have a bracket to show that it's closed, and then a comma, and the highest value comes next, and that's a 3. Again, it's included, it's a closed circle, and so the domain is the closed interval. It's bounded from -1 to 3. Now the range is bottom to top because our intervals are always least to greatest, and our smallest or lowest y value is down here at the bottom where x is 1 but y is -2. And then our highest y value is way up here at the top where the x is still 1 but the y is 4. So notice the x's are the same here, but the y's are different values, which means this graph, it fails the vertical line test because for the same x we have two different y's. So we know that this is not a function, it's a relation only. And then coming back here to fill in the range, we've got a closed lower bound, so we'll use a bracket, and that's where y was -2. And then at the top we've got a closed upper bound where the y is +4, so that 4 also gets a bracket. Okay, and that would be the domain of -1 to 3 inclusive, so it's a closed bounded interval, and the range -2 to 4 inclusive on both sides, so that's again a bounded interval that's closed. Okay, then in example 2, here we have a smallest x value of -2, and our highest x value is +2. So that represents the domain. The lower bound of -2 is inclusive because of that closed circle on the graph. But the upper bound for the domain is +2. That's an open circle. So +2 is non-inclusive, and that means that this is only half open, this bounded domain. Then the range is looking at the y values. Our lowest y value is -2. There's a closed circle, so that's inclusive. It gets a bracket. And our highest y value is +4 on this graph, which is a closed circle, so that is also inclusive. And so we've got a bounded interval that's completely closed from -2 to 4. And this piece of a polynomial, it looks like this curve here in between these two endpoints passes the vertical line test, and so yes, that is a function. Okay, then in the third example on this page, looking for the domain, we've got lowest x value here at -2, and it's an open circle, so it's non-inclusive. So we'll start with a parentheses at -2. And then if there's no closed circle, you can assume that that endpoint is closed here. If it was non-inclusive, there would have to be an open circle. So if you can't tell, always, if you don't see an open circle, assume it's closed. So here at this endpoint at 4,3, our highest x value is the 4, and we're going to close that with a bracket to show that the 4 is inclusive. A parentheses on the -2 shows that that lower bound is non-inclusive. Okay, then our range, the lowest y value on this graph is -1 at an open circle. So we'll start with a parentheses -1. And then our higher y value, it maxes out up here at 3, and that's closed. So we put a bracket. Okay, and this piece of a line here, that's going to pass the vertical line test, and so yes, that is a function. Okay, if you would try these next two examples, A and B, on this slide, and go ahead and pause the video before I reveal the answers, try them on your own, and then once you've got the domain and the range and decide whether it's a function or not for both A and B, then you can turn the video back on and check your answers. Okay, so assuming that you have tried these on your own now, we'll look at example A together first. The lowest x value is -3, and it's an open circle. The highest x value is +3, and that's a closed circle. So this is going to be the interval from -3 to 3. It's half open, where the lower bound -3 is open. The higher bound of 3 is closed, and the range is from bottom to top. We've got a lower bound here of -3 in the range, and we don't see an open circle, and so that's going to be considered closed then at -3. When we get to the higher value for the y, we see that it maxes out here at 0. On this side, on the left, it's open. On the right, it's closed. And students often get confused about what to do when it looks like that value is both open and closed. But when we're talking about the range, we're asking ourselves, what values could y possibly have? And since it's closed here at this endpoint at 3, 0, it's possible for y to be a 0 there. So we're going to count that as closed then on both sides. So the interval is bounded between -3 and 0, and it's inclusive on both ends. Okay, this is a semicircle, and that is a function. It passes the vertical line test. Now in example B, the domain, we have the smallest x value is -1, and that's closed. The highest x value is over here at +3, and that's open. So our bounded interval is from -1 to 3. It's half open because this upper bound of 3 is non-inclusive. Then looking at the range is bottom to top. Our lowest y value here in the range is -5, and that's inclusive because of the closed circle. And in this example, where students sometimes get confused, is their eye tends to go to this end point, but notice the end point is lower than the actual highest y value. And for range, we want to know all the y values lowest to highest. So we've got this lower bound here at -5. The upper bound for the range is all the way up here at 4. Notice that's higher again than the end point. So we're going to have the interval -5 to 4. It's completely bounded and closed on both ends because this is inclusive with the 4 and the -5. And that's a piece of a parabola, and that does pass the vertical line test, and it is a function. Okay, so make sure you've got these examples written down in your notes. Email me if you have any questions, and we'll move on to the next example in the next video. Thanks.